someone, it may not, okay? And what I'm going to try to do, and try is the operative word because I like to ramble, is go through the basics of algebra. What is algebra? Well, we're used to basic math where 3 plus 3 is equal to 6. But algebra is when they insert an unknown quantity, often called x, and you need to figure it out. Well, it's very clear from the statement up above that the missing quantity here, x, must be equal to 3. It's the only way that this formula will work. And that is algebra, figuring out x. Now, algebraically, even though it's logically obvious, you use the rules of math. And as you all know, there's something called order of operation. And the BEDMAS is how we remember it. And that says brackets first, exponents next, division, multiplication, sort of treated at the same time. And finally, you're doing addition and subtraction. Well, when you unravel an equation, from algebra, you actually do the reverse. And it's okay if you don't want to, this is how I teach people to remember it, but you don't have to do it this way. But just to let you know, it's sort of the reverse. You have to look and remove, and this is to isolate x. This is when you want to isolate x. You have to do the reverse. You have to remove addition and subtraction first. Then you have to remove your division and multiplications. Then you have to remove your exponents. Then you have to remove your brackets. And if it repeats within the brackets, you have to start again. Start again if more in the brackets. So you just keep going like that. And that is a good way to remember it. Now you might say, well, that's overly complicated. And you're right, it is overly complicated for the example I give on the left, but it's not for bigger problems. So let's start with this one. How do we unravel x to get alone? Well, there's a commutative property of addition. Sorry, if I'm not writing it clearly, communicative. And that means that 3 plus x is the same as x plus 3. And that means any addition and subtraction that happens in a situation, you can rearrange it any way you want, and the answer will be the same. And this makes a lot of sense if you put actual numbers in there. So, for instance, plus 7, or even the minus 3 plus 7, is hard to figure out. Unless I use the commutative properties and just put plus 7 over here, keep the minus 3 over here, it's clear it's 4. And this is true even if you do it the long way, and you use the number line and you count up from 7 and you come to positive 4. But you can see how much easier it was when I rearranged it. So that's something you should keep in mind. The other property that you're going to use a lot is called the distributive property. And this says that if I have a 3, let's say, in front of a bracket where 2 plus 4 are being added, the best way to solve this is multiplying the 3 times the 2 and then the 3 times the 4, the plus 4. And it's always, when you don't see a sign, it's always plus. So what's 3 times the 2? It's 6. What's 3 times the 4? It's plus 12. So you see that I've multiplied 3 to both those things to create this, and then when I add them, it's 18. Well, let's solve it within the brackets first, and just remember 18 was our answer. Within the brackets, I can easily just solve it as 6 and multiply 3, and it's clear, it's 18. You could say, well, why didn't I just do that? And you're right, you would do that, unless there's an x in there, right? Suppose that there's 2 plus x in there, and we all know it's going to equal to what? We all know it's going to be equal to, let's say, 24. And you're asked, what is x? Well, that's a lot harder, isn't it? You can't now just add 2 plus x. But let's go backwards and talk about x, because x alone freaks out a lot of people. X alone freaks out a lot of people. A lot of people say, well, I don't understand what x is. X is just a letter that we put in there to later represent an unknown number. And that's the easiest way. And it's also called a term because it's not a number, it's a letter. So we call it a term. And it can take many forms. It doesn't have to just be x. You can also call it a. 3a is equal to 9. 3 times a is equal to 9. What must a be? It's clear a must be equal to 3. So you can use any letter to represent things, and you can eventually you'll see that you can use combinations and even exponents in front of over the x, and even square roots and all sorts of things. You just end up treating x like an unknown number, and it's called a term. So there's a couple rules about that, and I'd like you to think of x as apples. And when x has just got no exponent, it's an apple. It's fine. But let's say that x has a square over it. You want to treat that as a different term. So while this is apple, this is oranges. Okay? And if this had a 3 over it, this is bananas. These are not things you can add. I can't add 1 apple, 3 oranges, 3 bananas and tell you that I have 4 pineapples. It makes no sense. What I want you to think of is the phrase like terms. Like terms. And that means I can only add things that are similar. Now, before I get on to like terms, let's go back to x being an apple. Suppose I said you have 1 apple, and I give you 4 more. It's very clear that you have 5 apples. You did it very easily. If I say I have 1x, or just x, and I give you 4x, a lot of students go, what? Well, it's the same as 1 apple, and I'm giving you 4 more apples, so you have 5 apples. So when you add things, you can only add them when they're the same thing, when they're all apples. That's the rule. So rule number 1. You can only add like terms. Write it down, because I'm going to get rid of that rule. It's not going to necessarily be around the whole time, because I always run out of space. Rule number 1, you can only add like terms. Okay, let's try that out. I have 5x plus 2y. Oh, I'm using a different term. Just call it bananas. Plus 3x plus 5y. And it doesn't matter what it's equal to. Let's just say I want to know what that equals to. Well, spot the like terms. There's a banana and there's a banana. How many bananas do I have? I got 5 here, 3 here, so I have 8 bananas. Spot, did I say apples? I can't remember. Spot your apples. Okay, there's some apples and there's some apples. I have 2 apples and 5 apples. How many apples do I have? Plus 7y. You might say, how do I know it's plus here? Well, all of these things were being added, so it's still going to be added over here. But all I know so far is that I've got 7 of these apples and 8 of these bananas. They cannot add apples with bananas. So for now, that's the best I can do. I have 8 apples and 7 bananas. So I just want you to get used to like terms. Same with subtraction. They follow the same rules as numbers. And it's very important you remember your rules of numbers and write it down somewhere. When multiplying numbers, a plus times a plus, and this is true for dividing, a plus times a plus, or a plus divided by a plus, is equal to a plus. A minus times a minus is equal to a plus. So the easiest way to remember that is if they have the same term and they're multiplying, they become plus. Anything else becomes a minus. So a minus times a plus is equal to a minus. And same within the opposite direction. It's equal to a minus. So that's true for multiplying. I need you to remember that. Any 2 numbers or terms that are multiplying or dividing that are plus, stay a plus. If they're both minus, they become a plus. If they're opposite signs, they go to minus if they're opposite signs. Now for addition and subtraction, when I am subtracting a minus number, essentially it's going to look like this, minus minus 3. You have 2 minuses in a row. That is the same as saying plus 3. So that's one rule. Okay? When I am subtracting a positive, it's very clear. So if I'll use a 8 up here. Okay? So that's the same as 8 plus 3. 8 minus minus 3 is the same as 8 plus 3, so that's the same as 11. If I'm subtracting a positive number, so 8, this one's the one you're familiar with, we don't even write the plus 3 beside the 3. We often just say 3, because when you don't see anything in front of the number, it's assumed that there's a plus there. And what is 8 minus plus 3, or 8 minus 3? Obviously, it's 5. When I'm adding a negative number, so when 8 plus minus 2, it becomes a negative number. So that plus minus in a row becomes 8 minus 2, which is equal to 6. And of course, when I'm adding a positive, it goes without saying that 8 plus 2 is the same as 8 plus 2. We don't even say the plus in front of the 2, which is equal to 10. So that's the other. If you're going to memorize rules, these rules are the same for numbers and terms. So I need you to remember and write down those rules. Pause the video if you have to, but it's important that you understand. Let's go back to terms, and I'll just keep the rule of terms. If I can, I'll get rid of the numbers. But numbers is very important. That means if I have an x subtracting a negative x, and let's use real numbers instead of just x. If I have 2 apples and I'm subtracting negative 2 apples, it follows the same rule. I am subtracting a negative. That is the same as 2x plus 2x. I have 2 apples. Are they the like terms? Yep, they're both apples. I have 2 apples plus 2 apples. It is 4 apples. If ever you want to thoroughly understand that, remember what multiplication is. Multiplication is just an easy way of saying 2 times something is the same as x plus something. So when I'm adding 2x plus 2x, well, this is 2x here, and I'm adding 2 more x. It's very clear to see that I have 4 of them. It's 4 of them, 4 apples. It's very clear. Let's look at the multiplying now. There's a little bit special thing that happens with multiplying. And terms. When I write the term x, all you see is x. You don't see the positive, and you know it's there. But you also don't see the positive 1 in front of it. Any number times 1 is equal to itself. And all around any number, even let's say the number 9. The number 9, even though we don't write it, is over 1. It's this fraction. It's 9 over 1. We just don't bother writing that. There's no point. It's also got a 1 in front of it. 1 times 9, technically. And it also has an exponent of 1. It also technically has a 0.000 after it that we never write. We don't write any of this. It's a huge waste of time. But it's good to know that all those things are there to understand multiplication and the rules of math. So x is the same way. X has an invisible 1 multiplying it. It's also over 1. It has a power of 1. This power of 1 is important. And for you to understand it, you're going to have to go back to your numbers and learn your rules for exponents. And here's the rules of exponents. You can only add terms that are the same, or numbers that are the same, but different. So for instance, I can add, and I'll give you, I can add 3 square plus, let's see, yeah, technically I can't. Sorry, I'll say only multiply, sorry. And this might be too complicated. Yeah, you know what, I'm going to skip it. For rules of exponent, it's very important you study this to understand what happens to exponents. So when I multiply 1x to the power of 1 times 1x times to the power of 1, the rule says these are the same apples. So when I'm multiplying them, I have to add these exponents at the top, and I get x squared. To understand this better, pretend x is 3. 3 times 3, we're saying, is 3 squared. Well, that makes sense because 3 times 3 is 3 squared. So that's just 9. So it makes sense that x times x is x squared. What if you multiply x's with other exponents? What if I multiply x that's to the cubed times x to the squared? You told me I can't add these. They're bananas. They're not and apples. You're right, but I can multiply them because they have the same term in here. And the rule is the same. I add their exponents. That's x to the power 5. To understand that better, think of x as being 3. 3 to the power of 3 is the same as 3 times 3 times 3. And 3 to the power of 2 is the same as 3 times 3. And since I'm multiplying it, I'm saying, what's 3 times 3 times 3 times 3 times 3? That's 3 to the power of 5. It follows the same rule, just we're using an unknown quantity. So the rule of exponents says, I cannot add these things because they don't have the same term. The answer would just be this. And when we write them side by side like this, we're really saying they're multiplying. We just don't write that. And we move away from using the multiplication symbol x because it looks too much like this x, and we use a dot. Okay, so we cannot multiply things that are different terms. What about dividing exponents that are different? Okay, this is the same term and we're dividing it. So the rule here is we don't add their exponents, we subtract them. This is just resulting in x. There's just one x left over at the top. To understand this better, let's look at 3 to the power of 3 divided by 3 to the power of 2. Up top, if I were to rewrite it, that's 3 times 3 times 3. If I were to write it down at the bottom, that's 3 times 3. If I were to expand this, I can see that clearly that the left top has 3 times 9, and it's being divided by 9. Well, the rule is anything, as long as it's all being multiplied or divided, anything at the top can be divided out. So it's clear it's just 3. That's why x cubed divided by x squared is just x. If you want to see it cancellation here, these 3 cancel, these 3 cancel, and I'm just left with 3. You're again allowed to cancel as long as this whole process up here is multiplication and then division. You're not allowed to cancel in this situation. 3 plus 4 divided by 4. I'm not allowed to cancel this and just say that's 3. It's very clear that's not 3, by the way. It's very clear that that's 7 over 4. Well, 7 over 4 is not 3. So you cannot cancel things when there's a plus between it and some other term. I can cancel it. I'm allowed to cancel it if, let's say, it's 4 times 3 plus 2 in a bracket over 4. This 4 is multiplying this entire entity, so it doesn't matter that there's a plus there. I'm allowed to cancel here, and I'm just left with 5. If in doubt, you can see that up here 4 times 5 divided by 4, 20 divided by 4 is indeed 5. But it's a lot faster to do it back here. So these rules apply for terms as they do for numbers. It's very important that you learn your numbers first before your terms. All right, let's get into algebra. It's longer than I thought it would be already. It's clear in this situation what x is. But it's 3. It's obvious. Only 3 plus 7 can equal 10. But we have to solve it algebraically, which means we must solve it algebraically, which means we have to do it with math, braically. So it means I want x all alone. I want to get this x all alone. Well, what's happening to this x? It's got a 7 added to it. According to my reverse BEDMAS, that's the first thing I should start with, plus or minus. Do I have anything being added to x? Yeah, I have plus 7. So, how do you get rid of something that's plus 7 on one side of an equation? Well, you subtract 7. And here's the next big rule of algebra. Whatever I do to the left side of an equation, I subtracted 7, I must do it to the right. So that's another huge rule. And I'm kind of skipping rules in a way, but rule number 2, whatever you do to the left, do to the right side of an equation. And I'll try to make a bit of room there. That's a very important rule to remember, and it's true for chemistry as well. It's true for most of science, actually. It's called balancing an equation. You're not allowed to just mess around with an equation on one side without the other, with one minor exception that you'll learn later on, but that's really changing denominators. It's not changing the equation. So what happens when I have plus 1 minus 7, plus 7 minus 7? Obviously, they just disappear. What happens on this side when I take 10 minus 7, because I had to do it on the right side? 3. So it's very clear I've proven algebraically that x plus 7 is equal to 10. And you're saying, well, duh, and I don't blame you. But the point is, they try to get more and more complicated. What if I had 3x plus 7? Let's go to our reverse order of operations to isolate x. We only do reverse when we're isolating x. Well, it says normally you do multiplication first in order of operations, but we're doing reverse. So reverse says we must find out if there's anything being added. Is there anything being added? Yes, there is. There's a 7 being added, which means we must subtract 7 to get rid of that 7 first. Whatever I do to the left side, rule number 2, though, says I must do to the right side. These cancel out. I'm left with 3x is equal to 3. 10 minus 7. Okay, we've done all our addition subtraction. What about the next step? Any division multiplication? Yeah, this 3 right beside the x I told you earlier means 3 times the x. How do you get rid of something multiplying something? Well, you divide it by that number. Another way I love to think of it is you multiply by its reciprocal. And this is a better way of thinking of mathematically. But right now I'm just going to say you divide it on this side. Well, whatever I do to the left side of an equation, I must do to the right. 3 divided by 3, since it's multiplying x, they can cancel. I'm left with x is equal to 3 over 3, which is simplified 1. To test it out, take this 1 and put it back into this equation. And now you've got to follow legit order of operations to solve this equation. This is only used for solving x. It is not used for the rest when you're solving the equation with x. Okay, so now our theory is that x is 1 plus 7. And order of operations says brackets first. Okay, well, it's 3 times 1. Okay. Exponents, there's none. Any multiplying division? Yeah, it's 3 times 1, which is 3. Okay, next, order of operations, add 10. Does my left side equal my right side? Yes. Therefore, it's true. X must equal to 1 for this to be true. That is algebra. What happens when it gets more complicated? Okay, good question. Suppose I have 3x plus 7 inside a bracket plus times 4 is equal to 80. So normally this 4 wouldn't even be written like this. It would just be written in front of the bracket. And it's saying this 4 is multiplying everything in the bracket. Yeah, I could expand it, but then I'm going to have 2 terms with x. The way it is now, it might be better to get rid of things. So looking at your reverse order of operations, you might instantly say, oh, adding and subtracting, I get rid of this plus 7 first. But look at the bottom here. Brackets. This is in brackets. I'm not allowed to touch it until I solve the things above. So I'm not allowed to do that. I'm not allowed to jump straight to the 7. Okay, before the brackets, before I reach brackets, I got this, anything being multiplied, divided in there? Yeah, the 3 and the 4. Well, the 3 is inside the brackets. I can't get to number this one until I do these first. I can't do this one until I get to the brackets. But I do have a multiplication here that's outside of the brackets. So I can solve that. So remember, reverse order says I can't reach those brackets until I solve everything going on outside the brackets. Well, I have a 4 multiplying the whole thing. What do I do to get rid of it? I divide by 4. I divide by 4. And later I want you to practice instead multiply by the reciprocal, which ends up being the same thing. But sometimes over here, it's better to have it like that. In this case, it's not going to matter. So I'm going to divide everything by 4 on both sides. Rule number 2, both sides. Okay. The 4's cancel out here. What happens here? 80 divided by 4 is 20. I've successfully reached the brackets alone. I can now write the equation without the brackets because there's nothing going on outside the brackets. Now I can start the whole thing again. Is there any addition and subtraction going on? Yes, there is. It's got a plus 7. So I must subtract 7 from both sides. And I'm left with 3. These cancel. And I'm left with 3x. And what's this? 13. Yuck. It's not a very clear one, is it? No, it isn't. So now I've done that. Any division multiplication? Yeah, this x is being multiplied by 3. So I must divide it by 3 on both sides. These cancel out, and I'm left with, and I wish it would have been a bit more clear. I thought it was going to be, but I guess I'd used the wrong numbers. 13 over 3. And you might say, how do I test that out? You take your original equation, and wherever you see x, just put a big bracket, plus 7, and you're testing out if this is true. Okay. Now inside, to solve this, remember, we don't use reverse now. We use the order of operations. BEDMAS. Oh, yeah, BEDMAS. So, brackets. Yep, I have some brackets. I have these brackets, so I'll just get rid of them. But I got to solve everything inside this bracket. Okay? Oh, so right away, order of operations says I have a multiplication here first. I must do it. So to get rid of it, I could do 3 times 13 and then divide by 3. But since right in here, these things are all multiplying, dividing each other, I can just cancel. So I'm left with 13 plus 7 inside the brackets. I got to solve the brackets now inside. What's 13 plus 7? It's 20. What's 4 times 20? 80. And remember, this whole thing was equal to 80. So does 80 equal to 80? Yes, I've proved that 13 over 3 must be x for this equation. And that is algebra. And it gets more and more complicated. But using this is very helpful, and it's a good way. Now, you can always consult YouTube for more and more complicated solving. And remember, you can put those exact equations into Symbolab. Symbolab.com is a great tool to solve things. Desmos is another great tool, but for equations, this one's fantastic. You put the algebra in there, and it'll solve x for you. It'll tell you the ranges of x. So if you're stuck in a test, run to Symbolab.